In this video, we're going to look at using continuous functions to solve inequalities. And the main idea is we're going to determine where f of x is positive, negative, equal to 0, and undefined. Okay? And the way that we're going to do this is we're going to break it up into pieces. And these split points, we identify to identify where we break it up. We look at where the function is not continuous and or not equal to 0. And we define these as our split points. Then what we do is we split the domain into pieces. And then the last piece is for each piece, for each of these splits, we determine if the function has the same sign. So in each piece, the function will always have the same sign for each piece. Okay? So by understanding the sign within each piece, we can look at where are we positive, where are we negative, and where are we undefined. So let's start with taking a look at a graph. And if we look here, we're going to split the function based on undefined, not continuous, or equaling 0. So if we look at this graph, we're split along these 5 points. -1, 0, 1, and 2. And so now, in each of these intervals, minus infinity to minus pi, pi to -1, -1 to 0, 0 to 1, 1 to 2, and 2 to infinity. Within each of these intervals, the sign is the same. I'm positive here, I'm negative here, I'm negative here, I'm positive here, I'm positive here, and I'm negative here. So to determine where the function is negative, we just take all the intervals where we're negative. So this is x is in -3 to -1, unioned with -1 to 0, unioned with 2 to infinity. To figure out where f of x is greater than 0, we look at all the intervals where we're positive. And this would be, sorry, it's not -3, it's minus pi. So here is minus pi to -1. Now, where are we greater? This is for x in minus infinity to minus pi, unioned with 0 to 1, union with 1 to 2. Now, where we're equal to 0, we look on the function to see, okay, when am I 0? When am I 0? So this is at x equaling minus pi and x equaling 2. And now, where does f of x not exist is undefined. Okay. This is undefined. Well, at these split points here, it actually has a definition. So it's not at those points. But here, absolutely, it's undefined. So it's undefined at x equaling 0. But now, going back, I'm looking at these intervals, and I'm going, oh, I am negative at -1. So with -1, this point at -1, we actually include it. So you could just add that point, union the set containing -1, union, or you could say, you know what, for this entire interval, including that -1, from minus pi to 0, I am less than 0, and union it with 2 to infinity. And similar here, we can look at this interval and we can say, oh, at 1, I'm also positive at 1. So we can rewrite it from 0 to 1. And we can say over that interval, I am also positive. But the idea is we break it up into these pieces, and then we analyze inside the pieces and the split points. But those are two different steps. So let's clearly define this as a step-by-step process. We combine the terms using a common denominator. We factor the numerator. Then we identify the split points. We create a sign chart. We determine the sign of the intervals. We define where it's negative, positive, and does not exist using set builder notation or interval notation. So determine where the following function is positive, negative, 0, or undefined. Well, here I'm going to step 1, I'm done. F of x equals x minus 3. I'm a single common denominator. Step 2, factor. F of x equals x minus 3. I have factored it. Awesome. Step 3, identify my split points as f of x equals 0 at x equals 3, or x minus equals 0, which occurs at x equaling 3. X equaling 3 is my split point. So I've identified my split points. It's x equaling 3. Now we create a sign chart using the split point. Step 4. I'm going to create my sign chart. My sign chart is about my split points. So 3 is one of the breaks in the sign chart. There's no other breaks. But now I'm creating a sign chart for the function. So what I'm going to do is I'm going to look at each of these roots individually. X minus 3. Now to complete the sign chart, I'm going to look at what happens at the right end behavior of this expression. The right end behavior, x minus 3, goes off to infinity. So this is positive. Then the left end behavior, well, x minus 3, the left goes negative. So it does change sign. It goes from positive to negative. And where does it change sign? Well, about the split point of 3, negative. So I would be positive here, and I'd be negative here after looking at all of the chart. Okay. Now from here, I've got the interval minus infinity to 3, and I've got the interval from 3 to infinity. And I'm just going to put in here that this is 0. I'm going to put a little circle there to tell me, hey, I'm 0. Okay, so that is step 5, is creating those signs. Now, step 6. F of x is less than 0 for x in, and now I'm looking at this interval and I'm saying, where am I less? Where am I negative? I'm negative here. So it's the interval minus infinity to 3. F of x is greater than 0 for x in the interval, and now from 3 to infinity, I'm positive. And f of x equals 0, I can see on my sign chart, there's a 0 there because that's where the function was 0. And now it's x in the real numbers such that x equals 3, or you could simply write x equals 3. Okay. And f of x is never undefined. So we're always defined, we're good. And we have now told you where it's negative, where it's positive, equals 0, where it's undefined. Now this might seem like a really simple question, but we can make it feel much more complicated, but the steps don't change. So we give you this fraction question. We got a difference of fractions and we got to deal with it. Well, my step 1 is create a common fraction, create a common denominator. When I do this, I get x minus 1 over x minus 3 times x minus 2 over x minus 3 minus x minus 1 times over x minus 2 times x minus 3 over x minus 3. Now here, we're going to expand the tops. X squared minus 3x plus 2 over x minus 3, x minus 2, minus, expand the tops, x squared minus x minus 4x plus 3 over x minus 2, x minus 3, which equals x squared minus 3x plus 2 minus x squared minus 4x plus 3, x minus 3, x minus 2, which equals x squared minus 3x plus 2 minus x squared plus 4x minus 3 over x minus 3, x minus 2, which equals x minus 1 over x minus 3, x minus 2. Okay. So this was step 1. And now this here is step 2, factoring. And you'll notice that I rolled right into step 2. Right? So that's my f of x. F of x equals this expression. So now, what are my split points? Step 3. Right? F of x equals 0 when x minus 1 equals 0, which implies that x equaling 1 is a split point. And f of x is undefined when x minus 3 equals 0 or x minus 2 equals 0, which implies x equaling 3 and x equaling 2 are split points. Well, now I'm going to make, in step 4, my sign chart based on my split points. Okay. So, what are my split points? That's the first thing I'm going to care about. I'm just going to make sure that I'm splitting properly. I've got 3 split points. The points are 1, 2, and 3. Okay. Now, I look at my expression, and I'm just going to write the roots as they appear. I've got the roots x minus 1, I've got x minus 2, and I've got x minus 3. Now, I'm going to analyze each of these roots individually. X minus 1, what's the right end behavior? If I look at what happens with a huge number, I'm positive. If I look at what happens with a huge negative number or very negative number, I'm negative. So I change sign. Where's the only place this function can change sign? Because I'm factored, I know it's at 1. So that's where I change sign. Next row, x minus 2. A very big number, plug it in, I'm going to be positive. Very negative number, I'm going to be negative. And I do change sign. Where's the only place I can change sign? Is here. Now x minus 3. Big number is positive, small number is negative. I change sign. Where's the only place I can change sign? At 3. And now I multiply my signs. Minus 2 negatives is positive, 1 negative is negative, positive. And I'm just going to, for clarity, write the interval. Minus infinity to 1, 1 to 2, 2 to 3, 3 to infinity. And I'm going to write what the function equals at these points. Here it's 0, Here it's undefined, undefined. So here I'm 0, here I'm undefined, defined. This here is step 5. Now for step 6, f of x is greater than 0. Where am I positive? For x in the interval 1 to 2, union with 3 to infinity. F of x is less than 0. Where am I negative? Here and here. For x in the interval minus infinity to 1, union with 2 to 3. Where does f of x equal 0? This is for x equaling 2 or x equaling 3. Or sorry, this is for x equaling 1. If we look at the chart, the circle is at x equaling 1. Now, f of x is undefined for x equaling 2 or x equaling 3. Something like this is highly likely to show up on your quiz next week, where you're given some sort of function and you're asked to determine where is the function positive, where is the function negative, where is it undefined, and where is it equaling to 0. The reason why this is highly likely to show up on your quiz next week is because in 2 weeks' time, we're going to be doing curve sketching. And you're going to be analyzing these questions for the function, the derivative, and the second derivative. This will help you prepare for that. That way you're not learning how to do this and curve sketching at the same time.